Hi everyone, this is a video on class inheritance. I'm assuming you've all read chapters 6 and 7 on functions and classes in Zybook, and know how to write your own class. So far, the classes you've learned to write have been standalone classes. They contain member variables and functions. Other classes and functions do not have access to these members unless they create an instance of the class. This is where inheritance comes in. Inheritance allows a class to have access to the members and functions of another related class. This is how the structure of inherited classes is set up. You have a single class that's inherited. This contains whatever member functions and variables. And then you have its children classes. You can just have one, you can have multiple, and these have access to the functions and variables in its parent class. So I'm going to start with this class I've already written. It's a class that describes a regular polygon. You'll notice that I have three different access types here: public, private, and protected. You should have seen public and private before, but protected is a new one. I'll get to that in a minute. In the public section, I have a constructor and two member functions. The member variables down here hold my constants and information about my polygon. Now, a polygon is a rather general description of a shape. It could refer to a number of different shapes: squares, hexagons, decagons. Let's say we needed a class with a more specific type of information. In our regular polygon class, there's no option to specify color, but say we wanted to give all squares a color. We would need a new class to specify what a square is. Problem is, as a programmer, we're supposed to be lazy. It's a good quality. We don't want to write an entirely new square class if most of the information, the variables, the functions, are all going to be from a polygon. It just takes too much time. The solution is inheritance. Inheritance allows us to say that we want our square to have all the same properties as a polygon, but maybe some more information. I.e., a triangle is a polygon, but a polygon is not necessarily a triangle. To show this relationship, let's write a square class. We need to include IOString. We haven't done that yet. We're going to have to include string and include cmath for our tangent function down here. So, let's start with the class definition. Let's call our class square, just like that. Now, to specify that we want our square to be inherited from a regular polygon, that is, to have access to all the stuff in here, we need to say that our class square gets access to all the public elements from regular polygon, just like that. So this will give this access modifier right here, basically does the same thing as this. It says we have access to everything public in regular polygon, not private. We also have access to protected. So protected is a keyword that says anything that's in this family of classes here. Remember from this image, if there are any of these, then we have access to it because it's protected as a family of classes. So now let's fill in the body of our class. We're going to need a constructor. We're going to model it on the constructor of the parent class, regular polygons, so square. And we need to pass in side length. We don't necessarily need the number of sides, so we can make that a preset argument. We know that a square will have four sides. So let's say double side length and double num side, or number of sides. I'm going to phrase it, yeah. Number of sides. and we're going to set this equal to 4, so we don't have to pass that in. It's just going to be assumed to be 4. We're also going to need to pass in the color, assuming that's what we want, how we want to differentiate our square. So we can do that, and we'll set. Now, since we have access via the public accessor here to everything that's protected and public in regular Polygon, we can actually directly access these variables, num sides and side length. So we're going to start with side length. Side length equals our argument here, side length, of course, and num sides from up here in regular, remember we're accessing that directly, equals number of sides, and we need a color variable of our own to store our color argument in. So color equals color. No, that's a bad conflict. We'll call it call instead of color. So there we go. We have a new constructor, and we have a private member variable just for square named color. Since square is inheriting from regular Polygon knows nothing about the string or the member variable color. It only knows about itself. But square here knows about color from itself and about everything in here. Num sides, side length, PrintInfo, CalculateArea. You can even use the constructor for regular Polygon if you want to. Now say we want to print out the information of our square. Regular Polygon has a function for printing out basic Polygon info. We can actually use this PrintInfo function when we want to make our own PrintInfo function down here. So let's do that. PrintInfo. Give it the same exact name as the one in the class above it, its parent class. And we're going to say we want to actually call PrintInfo from regular Polygon. So we're going to say regular Polygon and use the scope operator to go inside the regular Polygon class and access PrintInfo directly. So this will do, when it gets to this part of the PrintInfo function, it will do this. But we want it to do this and display our color. So let's print our color to the console. And that right there will override the function up here. So when we're using our square class and we call PrintInfo from it, we'll go in here, use the PrintInfo function from regular Polygon, which has access to the exact same variables up here, and then it'll continue to do this. One thing I forgot to mention is that the regular Polygon, the parent class, has to have a default constructor. This is kind of a quirk of C++, is that whenever you have an inherited, or a child class, the parent class has its default constructor called JustByDefault. So we're going to add that in real fast. Doesn't need to be anything fancy. That's all there is to it. So let's go down here and see an example of this in main. I'm going to start off with an integer variable called side length, and we'll set that equal to 2. Just give it a random side length. And we'll start off with a polygon. We'll make it a pentagon, 5 sides. Pass it in the side length up here, double side length, and we're going to print off the info, a pentagon, and let's see how that works. Here's the info printed out by pentagon.printinfo. You can see got the number of sides, length of sides. Looks right. Nothing too complicated, no surprises. So let's do the same thing with a square class. Let's make a square class. Call it square. We're going to pass in the same side length, and we're going to give it a color. Say yellow. Now, let's print out square's info. PrintInfo. I'm going to set a breakpoint up here in PrintInfo. You can see how this works. Might as well put it up here. We'll walk through it step by step. So, now let's run it. So paused here in the constructor of the square. See that we have access to the variables side length, which have garbage in them right now, and num slides, which are nowhere to be found in the square class. But somehow we know about them already. We can call them, use them. It's because they're in the parent class up here, declared here. Let's step through that. Color gets assigned. Color is local. Oh, looks like we have a problem here. Let's change that to call. Rerun it real fast. Okay, now we have the right variable in color. There we go, yellow. Perfect. Now let's step into PrintInfo. Here we go. So now we get to we're calling regular polygons PrintInfo from inside square. Go in here, just like a normal function call. As you can see over here, we're having these things printed out. Oops. Don't know what this is. Oh. Alright, well, skipped a few steps. Long story short, we get color yellow in addition to the regular PrintInfo from up here. Now, what if we wanted to know the area of our square? Our square class has no function for calculating the area of square, or any polygon for that matter, but its parent class does, right here. We can call the square CalculateArea, or the polygon CalculateArea, directly from our square object. So let's go down here, and let's output square.CalculateArea. So notice, CalculateArea is nowhere to be found in here, but because square inherits from regular polygon, it has access to its public variables and functions, namely CalculateArea. So we can calculate it right here. Let's see what this outputs. And go through there. Perfect. For a side length of 2, we get an area of 4 and a little extra. That's exactly what we were looking for. Now on to another example. I'm going to add a new class here called Triangle. And if you'll notice, Triangle doesn't have a PrintInfo function. It has CalculateArea 1, but not PrintInfo. So what I'm going to show you next is one of the coolest things about inheritance. Our child classes, the ones that inherit from regular polygon, so triangle and square, they can be held in a vector of regular polygon pointers. So let's go up and include vector. Perfect. And we'll declare one. Delete that. Vector of regular polygon pointers. Now, pointers is important. Can't do this with the straight up class. Got to use pointer. Call this polygons. Okay, so we have square here. Already have our square started. But let's get a square pointer. We'll still call it square. And our square equals a new square. Just like that. Let's also create a triangle one while we're at it. A triangle pointer. Triangle equals new triangle. And we'll pass it in side length. Alright, and let's put these into our polygon vector. Push back, square, and push back triangle. Now, let's create a for loop here and iterate through our vector. Polygons size. Alright, so let's say for each of our polygons, square and triangle, we want to print out our info. Polygons dot, actually access it there, and PrintInfo. I'm going to access it with the pointer accessor. Let's see what this prints us out. Or actually, let's guess first what it's going to print out. We'd like to see that squares PrintInfo function gets called, but let's find out if that happens. Here we go, start it. So here's what it prints out. This is just the normal PrintInfo function for regular Polygon. It never got to color, as you can see. So it's going through here for some reason, when we want it to be using this. In order to make our generalized pointer for regular Polygon use squares PrintInfo method, we need to declare regular Polygon's PrintInfo method a virtual function. Virtual function tells the compiler to go look for other PrintInfo definitions in the child classes. This allows it to choose which one to run actually in the end, and that's called polymorphism. Is the ability for the compiler to decide which function to run at runtime. So let's see what our function prints out now. Let's look. So see here, after we added the virtual keyword in regular Polygon's PrintInfo method, it goes and looks for squares method. See, we're getting our color yellow now, just like we expected. Additionally, as you can see, since we don't have a PrintInfo method in triangle, it automatically knows to use the PrintInfo definition in regular Polygon. Now there's another use for the virtual keyword here, and that's in something called an abstract class. The classes we've learned about so far have member variables and functions. In an abstract class, you can have member variables still and function prototypes, but you can't have the actual function definitions. You can't even have a constructor, just a default one. You'd use this if you had a class where you didn't actually care about making an instance of the parent class, regular Polygon. You just wanted your children to have particular qualities, like a number of size, number of length, or if you wanted to make sure that they made a particular function. So it's kind of like a message to any programmers that come along after you, telling them you need to make a function, this particular function. To do that, to set up an abstract class, you need to get rid of all your function definitions. So I'm going to get rid of this, and we're gonna come back to that. We're gonna have to get rid of that. We don't need a CalculateArea. We don't need our non-default constructor. Still need this one. Don't need a specific one. We're gonna declare this PrintInfo function that we want all of our subclasses to have as a pure virtual function. Do it like this. Add equals 0, colon. It's just a function prototype, equals 0. This signifies that you're not actually going to put a PrintInfo function here, but you want all the subclasses to have it. So let's see what that looks like. You see we're getting an error here. Triangle is not allowed because it doesn't have a PrintInfo function. So we need to give triangle a PrintInfo function. Declaring this a pure virtual function, here, pure virtual function, means that this has to have a print function so that it can override it. So void PrintInfo has to be named the exact same, have the same prototype, or function definition as up here, declaration. I'm going to put that in there. That's all we need, all the information we need. And this actually doesn't exist anymore, so let's put the raw text in there, just like that. And let's see if we can get this to run. Perfect. So overwrote it, and now regular Polygon has no definition for PrintInfo, but it knows that each of the polygons here has to have one, so it's legal syntax. And that concludes my video on inheritance. And thanks for watching.